under integration. This is from the syllabus, right? It is the line integral. So why should you look at this line integral is the question number 1. Line integral to determine length of a curve. Given by essentially y is equal to f of x or x is equal to g of y. It's a graph. Now that I want to determine the length of that curve. Between the given limits. That length of the curve L is equal to what? Integral dl along the function. In Cartesian coordinate systems, it is equal to integral of root of dx square plus dy squared. Is equal to integral x1 to x2 with x limits. Root of 1 plus dy by dx whole squared dx. Or the same thing is equal to integral y1 to y2 root of 1 plus dxy dy whole squared into dy. Ask if you have any doubt. Okay. Length of the curve between the given limits. If it is in the Cartesian coordinate system, the other coordinate system that I would like put is what? Circular coordinate system. The same thing is equal to integral root of d rho squared plus rho squared d phi squared under root. You know why this is coming also. dl is equal to dl bar is equal to d rho a rho plus rho d phi a phi. This is equal to integral phi 1 to phi 2. Properly we should take root of rho square plus d rho by d phi whole square d phi, or the same thing is equal to integral rho 1 to rho 2 root of 1 plus rho squared d phi by d rho whole squared d rho. Length of the curve. No, there are no problems, but maybe because you will get used to solving the problems, but still, I just want to speak about that also. In three-dimensional coordinate systems, curves can be given like this, standard curves. Number one, in 3D. One case, the other cases basically will follow. X independent, f of x is y, g of x is z. This is y, this is z. Can be given like this, a curve. Because if only one variable is independent, and then these two are now dependent, it is actually root of 1 plus f dash of x squared plus g dash of x squared dx, or f of y, y, g of y. If it is given, I will write it as f dash of y squared plus 1 plus g dash of y squared dy, or okay, okay, f of x, g of 1, f of z, one function, g of z, z. Then in the limits, integral, integral, integral. First one will have x limits, next one y limits, next z limits, because they are independently defined like that. This is f dash of z squared, g dash of z squared plus 1 dz. Or they can talk about this also. Second case, x, f of x, z is equal to constant. On a constant z plane, it can be a function x f of x. It's a graph. In that particular, z is equal to constant means what? Dl bar is dx ax plus dy ay only, because of which here it is root of 1 plus f dash of x squared dx integral on y f of y, z is equal to constant. They can give like that. Now we can write it as what? Integral of root of 1 plus f dash of y whole squared dy. Like this we can define. In x is equal to constant plane, we can define. Y is equal to constant plane, we can define. Z is equal to constant plane, we can define. Right? So in a similar way, we can talk about the cylindrical coordinates also. Okay. Next. Line integral of a function. what is this line integral of a function? The best example we will find it actually is that given the line charge density, this is where we are at a better position, right, to get into this. Given the line charge density along a line, line is a curve, it can be. Line charge density can be rho L of x or rho L of y. I can write if listen, rho L of x. If rho L of x is given along a line, y is equal to f of x. Everywhere x is the independent variable. While taking the line charge density as well the defining the function. In this case, total charge q on the line between the limits x1 to x2 is what? Rho L of x, function of x, dl. dl is what? Root of 1 plus f dash of x squared dx. Please appreciate that this is dl per unit length on that line at any x. Rho L of x root of 1 plus, or the other way around, it can be integral y1 to y2 rho L of y root of 1 plus g dash of y whole square dy, where x is equal to g of y. I can always put rho L of x. In the place of x, I can put g of y. Correct? In the expression, wherever x was there in rho L of x, if you put g of y, it will become rho L of y. Then if y is equal to f of x, g is equal to, sorry, x is equal to g of y, where g is inverse function to f. Check it. There are several cases. No, please check whether these things are clear to you or not, because I cannot give, I don't want to give all the cases in this. Line integral of a function. That function is this. Next. Another extremely important application of line integral for us is to compute electrical potential difference between 2 points in the electric field, or the mechanical potential difference between 2 points in the gravitational field, or essentially the work done in moving an object by applying a force F. Normally, along a path is always true. Potential difference between 2 points in the field along a given path If it is independent of the path, conservative field. Mathematically, I can define the field in such a way that it is not conservative. Also that between the same 2 points, if you follow two different paths, the value of the integral is different. In this particular case, one particular integral that we want to use here is, for the sake of potential difference, electric as well as mechanical. And work done by a force. Listen carefully. We evaluate the integral of the form integral A to B. Specifics we will discuss in the topic. Integral A to B, whatever is given, you have to follow that. Integral A to B, V bar dot dl bar. When the topic comes, you will be really at a better position. This is what we evaluate as the integral vector as a function of xy. Here, this is equal to integral A to B for along a given path. Very, very important thing is along a given path. Vx of xy in the plane I'm just talking about. It can be xyz also. Vx of xy ax plus vy of xy, some other function. Ay dot dl bar is what? Dx ax plus dy ay. This really takes the form of what? Integral A to B Vx of xy dx. I will not write it as xy now. Anyway, we know that Vx is a general thing. Plus Vy dy. Y component of that vector into dy. Along a given path, I have to evaluate. Very, very important integral for us. In multiple ways, it is important for me. Check it once. Along a given path, wherever it is, at any point, it can be otherwise what? Initial point A to B, Vx dx, I think you understood this, plus Vy dy plus Vz dz along a given path. That is critical actually for us. Along a given path, we could have given it as what? Y is equal to f1 of x, z is equal to f2 of x. I have Vx, Vy, Vz. In general, they are functions of x, y, z. But ultimately, I will only say single line integral, right? Because of which my independent variable can only be one variable. And the limits are basically for that independent variable. Among these three, anything can be given as the independent variable, the remaining two are dependent. Only for that, we will put the limits. Wherever x is there, I will put f of y. F of y is equal to f of x. Wherever y is there, f of x I will put. Wherever z is there, g of x I will put. So ultimately, dy can be written as in terms of dx, dz can be written in terms of dx, because of which y is equal to f of x, dy is equal to f dash of x dx, z is equal to g of x, dz is equal to g of x dx, g dash of x dx. You have to evaluate such integrals to determine the work done by a force or the work done by the gravitational force or work done by the electric field force in moving a unit charge or unit mass, whatever it is. These are the three things that we want to look at. Maybe I would have taken some cases. You have to basically understand the basis here, right? The concept here. Check the problems now. Number 1. Oh, starting only actually. Okay, doesn't matter. Evaluate the integral along a curve C, shown in the figure. 2x y squared dl. And the curve is circle, part of a circle, right? X square plus y squared is equal to 1. Integral. Check it. 0 to 1. 2 into root of 1 minus y squared into y squared dl is root of, I'm writing it everywhere in terms of y now. Root of 1 plus, what is dy by dx? Dx by dy I have to write like 2x dx by dy is equal plus 2y is equal to 0. Do you agree that? Because I want to get dx by dy. It is 1 plus dx by dy whole squared into dy. 1 plus dx by dy is what? Y by x, which is now y squared by x squared dy. Please look at it. Things are good here, right? Next. What will happen to this? Integral 0 to 1 to y squared root of 1 minus y squared root of x square plus y squared by x. Correct? By x squared in the root dy. Where this x is equal to root of 1 minus y squared. This is equal to ultimately what? This x square plus y squared is equal to 1, I know, along the path. 2 times integral 0 to 1. What ultimately that comes? Y squared dy, which is 2y cubed by 3 from 0 to 1 is by 3. See the good thing now. I can evaluate this taking the problem into circular coordinates also. In circular coordinates, X is equal to, along the circular path only I want to go, of radius 1. X is equal to what? Cos theta. 2 into cos theta. Y squared is? Y is equal to sin theta. Please see this. Sin square theta. DL is what? Along the circular path, what is DL at any sorry, cos phi. Our notation was phi. Maybe it can be theta also. 2xy squared. DL is what? Along the circular path. R d phi. R is equal to 1, because of which it is d phi. See the beauty of it? How easy it is, what you have to look at. Zero to pi by 2. Correct only, no? Phi varies from 0 to pi by 2. Along the circular path, dl is equal to 1 d phi. Now, this is where I want to show you the distinction. No, if you use the appropriate coordinate system, what is this? If I evaluate this integral, put sin phi is equal to t. With sin phi is equal to t, cos phi d phi is equal to dt. This will become what? 2 integral t squared dt is 2 t cube by 3. T is equal to sin phi. So it is 2 by 3 sin cubed phi from 0 to pi by 2 is 2 by 3. Please see. Number 2. Integral -1 to +1, I want to evaluate. X y cubed dl, royal dl. Along the line, y is equal to 2x. At each and every point along the line, y is equal to 2x. Hey, what will happen to this integral? Oh, x is equal to -1 to +1. What will happen to this integral? Integral
8
-1
to the
to
power of
1.
X become 8x to the power.
8x cubed root 1 plus 2 squared divided by dx is what? 2 dx is equal to root 5 -1 to 1 plus 1 into 8x power 4 dx, which is root 5 into 8 by 5 x power 5 from -1 to +1 is 2, right? 8 into 2 by root 5, 16 by root 5 is the answer. Check it.